Hi everyone, this is Billy. I'm sure some of you have tried to put components in the fuse tube like I did now. Bend the legs and try to push the cap in. Sometimes it takes a lot of effort. Sometimes you will even break the glass and hurt yourself. The other problem is it's always very hard to separate the cap from the glass tube. I was lucky that I find this type of incorrectly manufactured fuse where they have the cap made too wide, and then they end up using some glues to glue the cap back to the fuse tube. For this, we can easily separate them and use them for holding our crystal or diode. In case you can't buy those, so we usually will drill some holes big enough for the diode to go through, and then squeeze it in like that, and then we can solder the end, so we can still make a good fuse tube with diode. But that way you can't change the diode because it's already soldered. So today I'm going to introduce you a new method that you can create a fuse tube that is not too tight, that you can print out using the 3D printer. So I got one of these here, which is the same as this one. It is printed using the transparent PLA filament. So what we do is we can put any diode inside, bend the legs, put in the cap easily without squeezing too hard, like this. So this way you have a fuse tube 3D printed, and you can use it to mount onto the crystal radio. For example, this is the crystal radio that I created recently with 3D printer parts. I put in a common fuse holder that you can buy from the component shop. I'll put a link on my YouTube description. You can buy them through the Amazon link. And then we can insert it here. So it's very nice. And you can change your diode easily. And this contact is very hard, very firm, so you won't get into a problem of poor contact. I will show you how to create that in the Fusion 360. It's only 2 steps. Everyone can do it. Then you can print it out and create your own fuse tube diode or crystal. If you like my videos and would love to see more of this, please support my work by clicking on the links in my description to either use PayPal to give me some small amount of money, or contribute to my Patreon account for a monthly subscription, or purchase any Amazon product through the Amazon links I provided in the link. This may be components you need to buy to build this, or other components that you need. If you purchase through that link, Amazon will give me a tiny bit of money, but it won't impact your price at all. Thanks for your help. So if it's the first time you use Fusion 360, you can download it from the official site, then get a personal license or an educational license, and you can use it free of charge. Something about Fusion 360 is all the files that you created will be on their website, on the cloud, and so it will be very easy for you to share your file with others. On the other hand, you can also use this export command to export your file to .f3d, so you can store it locally as a backup in case the cloud system is not available. Then when the next time you run Fusion 360, you can import or open this file to get back your design. So let's start a new design. Click on the File menu, New Design. And then you have unsaved here, right? So let's put in a name. We can save it. Put in a name of fuse tube, something like that. And then the file name will change to fuse tube, and they will have a version number. Version 0 is the first time you save. If you save it a second time, it will become version 1. And then you can always go back and reopen the previous version. And then on document setting, you have the units. So if you are in US, you want to change that to inch. If you are in another part of the world, maybe millimeter, up to you. So this is the unit we will use when you measure the size. Okay. Okay, I move that back. Okay. Now we have the unit setup. So this is the named view. If you click this view, that means you'll be able to save some of the orientation, how you want to look at your setup. Home is returning to the initial setup. So you can visualize your design in the default manner. Origin is where you see these highlighted planes. Each one of them is called a plane. That means you can draw something on the plane as a circle, and then you can extrude it, make it thicker, and it becomes a cylinder. So usually we'll draw on the XY plane, and then we'll extrude it to make it a rectangle box or a cylinder, things like that. Right now, that's exactly what we are going to do. So we'll draw on this plane. So we select the XY plane, and then we type the command C on the keyboard. It is a shortcut for drawing a circle. And you see the circle tool come up here. So when we draw something, we want to draw it at the center origin. So later on, we can do a lot of things with it. If you draw it on the side, then you'll find that you regret very soon, because you can't use the default tools to mirror or do other things. So let's draw on the center. You click once on the left mouse button, and then the icon will change the shape of a circle. And as you move your mouse along, the circle will grow bigger and bigger, or you can get it back to smaller. So if you don't want to guess the dimension, you will usually measure the size you want using a ruler first, and then just input the dimension directly. So I've done some measurement. Let me take a look. So this is a screen capture of my previous measurement. So the size of the fuse tube, the outer wall is 5.8 millimeter, the inner wall is 4.5 millimeter, and the thickness of the wall is 2 millimeter. So we'll repeat that and draw it here. Okay, so let's first draw the 5.8 millimeter. Go back and draw the circle again. Click the XY plane again. Draw the circle. So we input 5.8 millimeter. Well, if it's too small, you can scroll the middle scrolling wheel of your mouse and make it bigger. And if it's all the way to the left side, you can click this pen button, the handshake icon, and drag it back to the center. And then press escape to get rid of the hand. Okay, now you see we have a dimension 5.8 millimeter, which is the diameter of the circle. Now we need to draw a second circle within this one. So let's highlight the circle, click the command C again. Let's draw a second circle. Diameter will be 4.5. Okay, if you think these two dimension lines description are too close together, you can click on that arrow and drag it elsewhere, so you can see it much easier later on. If you don't like the view you are seeing, you can click this cube at the top right hand corner, click on the top, and it will see the top. You can also rotate the wheel. So this is what you see from the top of the printer. And what we want to do is, okay, so we can click on the ring and make it an object. And let's click this orbit view changer, so we can change it to a more three-dimensional view. Now you see we can raise it to a cylinder, and how much we raise, we can input it. So we have 28 millimeter. Okay, so this become a real cylinder now. Next, we will need to drill some small slits so we can fit through our diode legs. We do that by creating a small rectangle. Press the S shortcut key to bring up the sketch menu, and then we'll draw a rectangle on this surface. So let's put in 5. And the size of that is around 1 millimeter. Okay, let's hit enter. So this slit has been created. Okay, and we need to press this slit into the wall. We select the shape of the rectangle first, like this, and then right click. Again, use the press pull command. This time we push it inside, and we change our function to cut on 3 only, not too deep. Okay, let's click OK. So you see a slit has been created. We want to copy this over. So how do we do that? We want to copy the slits at the top to the bottom to maintain symmetry. How do we do that? So there's a function called mirror. But before we do that, we need to create a plane so we can mirror on. So how do we create a plane? There's a construction menu, construct, and then you can select mid-plane. Click that. So it will ask you to select the 2 planes, bottom and top. Then it will create a middle plane in between. So let's select the top plane first. Okay, and then we need to select the bottom plane like this. So once you selected that, you'll see a middle plane has been created and will be mirroring on this middle plane. Okay, let's click OK. So this is our middle plane. We just cut the fuse tube in half, upper and lower. And then we need to bring up the sketch menu, S, press the S key, type in mirror. Okay, this is mirror. If you want to use it more times, right, not just once, then you can click this arrow button to add it onto your menu, so you can click on it quickly. You don't need to type mirror next time. So now that I've created it, let me try the S key again. I can see that there's a mirror icon here. I can just click it. So now we need to select what type of things we want to mirror. We can mirror the sketch, which is the face, or we can mirror the whole body, which is the solid, or we can mirror the feature. A feature means an indentation within the face, or a hole. It's just some solid shape that you want to copy, but not the entire solid body. So let's copy the feature. And then we need to select the feature. So let me select this part. Okay, you see that it's now highlighted in blue. That means it's being selected. And then we select the mirror plane. So that means we select the middle plane, right, to mirror on. Once we select that, the same shape, the same feature is replicated at the bottom because it's mirrored by the mirror plane. So let's click OK. And then now we can come and see it. So the bottom also has a slit. The top there's a slit. And then we are done. So we can get rid of this mid plane if we don't want it by clicking this eye icon here. So and clicking this eye icon to get rid of the plane. Okay, so those construction planes will not be printed. It's just there to help you design your features, make it easier to use the tools within Fusion 360, like the mirroring tools. The other thing you need to do after you finish the major design is to finish the edges. Because sometimes the edges are very sharp. If you print it out this way, the edges will likely fall off after use. Just click on that edge, and then click on this fillet button. You see the fillet button will round up your edges, so you will be looking more professional and easier to deal with. Let's click on it. And we'll need to give a size of the radius of the filler, like 1 millimeter radius. It's like drawing a circle of 1 millimeter across this edge to make it smoother. Or you can try 0.5, see what happens. Right, 0.5 is like this. So it depends on what you need. I think 0.5 is good enough. Okay, and then you can click OK. Okay, how do we replicate this fillet down to the bottom? So we can go back to our browser and turn back on that plane, that middle plane here. So we can do the mirror. So let's highlight this part, this surface where the fillet is created. And then we press the S key to bring up the sketch menu. Click on mirror. So you see we already highlighted this one, selected this face, and then we can select the plane, the mirror plane, which is this one. Okay. Let's take a peek. So this one is already being mirrored. The fillet is just mirrors down to the bottom. Okay. Let's click OK. Let's see the results closely. Okay, you see that this is already mirrors. The fillet has been filled in to the bottom as well. Okay. So let's remove the plane and get back our design. So this is it. That's our finished design with the fillet added. Let's save it. Click on the file, save, save, and you see that the version now jumped to version 1. And next thing we need to do is to print it, and you may want to save it as your backup file first. So let's click on this file menu and export. And then by default it's using the .3D, that means the backup file, archive file for Autodesk Fusion 360. File name is there, and then you can click export. So it is completed. Let's show it in the folder. Okay, it's being saved here. Okay, so assuming that you accidentally lost your file, so what do? The cloud is not accessible. Then you can click File, Open, and then you come here to look at the Fusion open from my computer. Okay, and then you find this archive file that you saved just now and click Open. Then you get back your design from this archive. And then you can now save it with a new name to the cloud again. But we're not going to do that. So now we are going to print it. To print it, we click File, 3D Print. And then if we want to print everything, we just click on the named view. So we will print all the models, all the components, all the parts on this design file. But now we only have one part, so it's being highlighted in this mesh wire diagram. So you just simulate all the threads being printed line by line. And then we can select our print utility. I'm using Cura, so we just select that and click OK. It will then launch your print utility. So it will launch Cura in my case. Okay, once you got Cura launched, you'll get this menu. And then you can use the mouse wheel in the middle to enlarge it or shrink it. You can use the right mouse button in your mouse to drag and change the wheel to see through the model. Look at the bottom where the holes are drilled, whether there's holes. And you can click on the middle wheel, hold it, and then change the position. Yeah, you can change the position up, down, left, right, so you can see it more clearly. Okay, once you are done with it, you can move it back. You can also use this icon to show you the default wheels. Okay, let's go back to this one. Let's see it from the top. And then we can do the slice. Slice means converting the design file into the G-code format, which are instructions to tell the 3D printer how to print. So we can click. Before we do that, we forgot something. We need to edit the setting here. Click on this button to edit the setting. So what we want to edit is the infill density. That means how dense we want the material to be. It's occupying 50% of the solid space. This will allow us to have a more solid print. The default value is only 20%, which is not firm enough. Okay, and then the other thing we need to change is the support. Generate support material. That means if you have something overhanging and it's hard to keep it in the mid-air without a support, then Cura will generate a pole or a column to support it. And then after printing, because the column is printed loosely, you can easily get rid of it using a knife or a scissor. That's what support means. But in our design, we don't need support because it's all supported by itself. The lower layer supports the upper layer, and we don't need another support. We don't have any overhanging. We don't have an arm of a tree hanging out, so we don't need support. So once we finish that, we click close to close it, and then we can go to preview. So the preview will simulate how many layers are being printed. You can see here 140, that means 140 layers are being printed here. 140 layers. You can drag this vertical bar, slide back to layer 1. Then you can see. Let's look at it this way. So you can see layer 1 is being printed here. This is layer 1. And then if you scroll up, more layers are being printed up to layer 140. That means the entire column, entire tube is being printed. And you can check the side to see if it's alright, is the slit being printed properly. Right, this is the slit. It's printed properly or not. Yeah. And then when you are fine with it, you can save to file. Or if you have inserted your 3D printer's SD card, you will see a save to removable disk here. Let me insert my 3D printer card now. So let me insert it now. Okay, once I insert it, you should see that this icon changed. And it will change to save to removable drive. So let's click, and then a file will be saved. So remember the name of this file. If you've got multiple files in your removable die is hard to find it because this number is random. So what do? You can edit the file name here, make it more meaningful, like fuse tube version 1, something like that, and then click enter. And then when you save it again, the file name will be saved as fuse tube version 1.g code, so it will be easier to find when you print it, when you choose it from the printer to print. Okay, let's eject and let's print it. So this is my 3D printer, the Ender 3 Pro. I've set it up myself and it's been helping me to print the parts. It's been very easy to use. Let me switch it on. But it's a bit noisy. The version 2 of Ender 3 version 2 is much quieter and it's 32-bit. So you can click on the link provided in my YouTube to go to Amazon to get it if you think it's a good 3D printer for you. It's quieter and more powerful. So let me insert, let me take out my removable DRAM, and I insert it usually face down into the Ender Pro 3. Okay, inserted, and then I need to change the card. So that's the init TF card. It doesn't mean we erase the TF card. It just say read the card again. And then once you do that, you have the menu. It's in Chinese. It means menu. And then once you're in the menu, you'll find the file that you saved. So we save it using the file name of fuse tube. Then let's click it. And then you start heating up the printer. So you will first heat up the print bed to 60 degrees Celsius. After that, it will heat up the printer head, which they call it the extruder. The printer head is this one. The extruder. The printer head is actually underneath here. So we'll continue to watch it until it's finished heating. The 3D printer has a movable print bed, and the print bed is usually made of steel. So if you got a magnetic blanket, or you can put it on top, and then you can print on this blanket. In the old days, 3D printers are more primitive. You need to stick some heat-resistant tape on top every time you print, and then slice it off every time you finish printing. It's a lot of trouble. Now they have this type of reusable blanket that you can just put it on and use it for months without problem. The only time you need to change it is you find some ditches or some uneven material stuck in here that you can't remove, then you need to change it. There's also a newer type of print bed. It's made of glass and silicon, and you can use that as well. That one is very easy to get your printed object off the print bed, because once they cool down, the structure of that print bed will change and then force the printed object to just release itself. So it's very easy. And the only maintenance you need on your 3D printer is number one, mount this type of filament PLA I'm using. You have a different choice of printer materials. PLA is the easiest to print. Otherwise you have the ABS, which is harder, but harder to print as well. And then the TPU, which is flexible. It's like those you can use on a face mask, which is flexible. It's like rubber more than plastic. The other thing you need to do for maintenance is to maintain this print bed. Sometimes you've got material stuck, and then you need to use this to get rid of it. And Sometimes if you try too hard, it still stick there, and you need to replace the whole blanket. The first thing you need to do is to level the print bed. There's some video about how you level the print bed. That means make sure the first layer can be printed nicely. Otherwise, second and the third layer will not be able to continue to build up. You see the extruder is being heated and some PLA filament material is just coming out of the print head. So let's see here. Extruder is 199 degrees Celsius, almost 200, the standard required temperature. So you see extruder is still being heated. Now heating is done because it's over 200 now. And then we see the print head and the print bed are moving to position to start printing. So first time it will print a straight line at the left side of the print bed, just to get rid of the previous residue print material, and then it will start to print a circle to circle everything that will be printed. It do that to make sure there's no blockage before printing the component within that circle. So after that first layer of circle is printed, we will start printing the object we are interested to print. So let's see, it's printing the first tube now, layer 1, very slowly. It's already printed 3 or 4 layers now. Initially, you can see it's printing up third and fourth layer very quickly. Now let's look at the print time. The print time, you can tell the print time here is, we already printed for 5 seconds, and that represents around 17%, 18% of the total print time. So you can kind of estimate what will be the total print time. So now we are 20% and we use just 5 seconds, right? So if we multiply that by 5 to give 100%, that means we need around 25 seconds to finish the print. And let's see whether that is true. Zoom back into this print head. So I think now we are at the middle of the printing progress. Let's see. 8 seconds, 50% done. That means we should expect 8 more seconds when this is done. Okay, we finished printing. We'll just take it off like that. And the slip is being printed nicely. The bottom as well. I think this looks good.